All right, today is a little bit of mix of everything we've done so far with the graphs and stuff, okay? Instead of like them asking us where is this happening, it's going to tell us where it's happening, and we are going to therefore make assumptions and be able to like sketch graphs knowing what's happening, okay? So in our warm-up here, we have a function. Is it linear or is it non-linear? Non-linear. Good. How do you know that?
It's all wavy and whatever.
It's all wavy. There are turns happening. Okay? So there's key features we can pull out of this. We see a relative maximum, a relative minimum. We see increase, decrease. Okay? What other features could we pull out of this graph that you see? What else could you tell me about it?
It's decreasing.
There's one interval of decrease.
It's changing size.
Okay, there's one interval of decrease. Tell me something that's not labeled though. There are, so how many extremas are there?
Two.
There's two extremas. Good, that's another one. Two extremas.
What's the first one saying?
One interval of decrease. So it showed me where it was decreasing. We're being specific saying there's one interval of decrease. Because how many intervals of increase are there? Technically, there's two intervals of increase. So that's just what we're specifying. There only one piece is going down. There's two pieces going up. What else? We could say there's 3 x-intercepts. If you wanted to say that. I know it only says give 2 examples. I'm just giving you options. You could say there's 3 x-intercepts.
So an extrema, it's like when it's carving.
Yeah, it's when it's turning. So an extrema is either a min or a max. It's kind of like the broad term. And then the min and max is when you get like more specific on what type of extrema it is.
Yeah.
Okay. Does this graph have any symmetry?
Yes.
Could you cut this graph vertically in half and it folds over onto itself? No, that's not happening with this graph. Okay, there's not a mirror image on both sides. Okay. So we're going to use this information to sketch stuff. Joelle, can you close it for me? And then we'll use it later. Thank you, sir. Okay, so here we go. We have a cycling example. So 2015, Christoph Strasser set a new 24-hour cycling record by riding 556 miles in a 24-hour period.
Wait, how much?
Okay, 556 miles. The distance he rode over 24 hours can be represented by a function. Sketch a graph that shows the distance traveled, y, as a function of time, which is x. So we are given lots of information about this. So what does it want us to know? Before sketching, consider any possible constraints. So if we're talking about time and distance, when it goes to riding a bike, can we have negative time? No, we can't have negative time, though. Are we going to have negative distance if he's doing if he's traveling the entire time? No. So that's why the graph that you see down here, it's only in the positives. Technically, that's the first quadrant, Janaya. Technically, it's the first quadrant, which is all of our positive x's and all of our positive y's. Okay? So that's what a constraint is what is not allowed to happen. Okay? All right. What assumption can be made when graphing his record-setting bike ride? Okay. So what can we assume about this bike ride?
That he went pretty fast.
He went pretty fast, and he did it constantly?
Yes.
Yeah. So we can assume.
His speed was like the same.
Yes.
Yeah.
Perfect. Yep. We can assume that the speed was constant over the entire 24 hours. So what kind of graph could I draw, do you think? Would this be a linear or a non-linear?
Linear.
It would be linear. If we're assuming it's a constant rate of change, we're going to assume this is going to be a line. Joelle, do you have a question?
No.
Okay. So they do give me some key features, okay? So a y-intercept Okay, it says no distance traveled when he has ridden for 0 hours. So what would my y-intercept be? 0. Yeah, if he hasn't traveled anywhere, if he hasn't started, he hasn't gone anywhere, right? So we know this is going to start at 0, 0. Okay, another detail. I'm going to zoom in so we can read this. Linear or non-linear. Again, we said that the graph is going to be linear because we're assuming the constant rate of change. So we're assuming it's going to be a line. And we're also assuming it's going to be positive, right? As my time gets bigger, my distance is going to get bigger. So the entire thing is also increasing. So it's positive because we have only positive values. And it's increasing, meaning my values will all go up. Okay? And behavior describes the same thing. As my x's increase, so do my y's. It's another way of saying it's going to be an increasing line. Okay? So how could I draw this line? I know if I don't travel with no time, what do I also know? I know his total, right? He did a total of how many miles? 556 in how many hours? 24. So we can make our best guess here. So here's 24 hours. So about 556. So like approximately right there. Would that be okay?
Yeah.
A little higher.
A little higher? I would not do a little higher. Because that block is 50 miles. So I would keep it pretty close. And then we can just connect these. It only takes 2 points to make a line. There we go. Something like that. I'm sure your lines are better than mine.
My line is terrible. I have a little curve in it.
All right.
Look at mine.
All right, so it's important to make the assumption that we made that his speed was constant to be able to draw the line, okay? But in reality, do you really think he rode his bike at the exact same speed for 24 hours straight?
No.
Probably not, okay? So in reality, he probably took breaks. Probably took breaks. Let's say during ride. During 24-hour ride. How about that? During 24-hour ride. Okay? But we're being like, because it says, how does the assumption affect the accuracy of the graph? So, if this was a real life graph of what he actually did, it probably would not look like this. We are assuming it was a constant rate. Okay, so that's what gave us a line. So we're doing like an approximation of what he did during his 24 hours. Okay, maybe some days he went faster. There was more downhill. Some days was slower. Maybe he spent the whole day resting, or not a day, hours. What I would say. Maybe he spent the whole hour resting. We don't know. He had to eat, right? He had to eat.
He ate on the ride.
Okay, maybe it's dangerous riding a bike and eating. Right?
You can't ride no hands.
So you see how we're like more analyzing today? More analyzing stuff going on? Alright, I'm gonna go to the back. We good? Anyone need this? Keep it close for me. Thank you. Thank you. All right. On the back, we have our next example that has to do with weather. Okay? A person's happiness, excuse me, can be affected by the temperature. Okay? Sketch a non-linear graph. Oh, so is it going to be a line this time? No, non-linear. Sketch a non-linear graph that shows the happiness of a person as, which is y, as the function of a temperature, which is x. Okay, and then we're going to interpret some key features. Okay, so details that they have given me. We have a positive and a negative. Remember, positive means positive y values. Negative means negative y values. Okay, or above or below the y-axis. Okay, so we are positive in between 25 degrees Fahrenheit and 89 degrees Fahrenheit. Okay, 25 degrees, would you agree is about right here? Ish?
Yeah.
Looks like those are counting by tens.
I don't like this.
Okay. And then 89, so about right here-ish. Okay. So between those two temperatures, it's positive. So is it going to be above or below those two pieces?
Oh, it's gonna be above.
It's probably going to be above. Yeah. Here, I'm going to do a little sketch over here. So we have 2 points. So we're assuming between those 2 points, we're going to be positive. We're going to be above those 2 points. Okay. I'm kind of sketching on the side because I need more details, right? I need to know how tall it's going to go. And then it says that it's going to be negative for less than 25 and greater than 89. So that verifies that the two ends are going to be negative y values. So we kind of have an idea of what the shape of my parabola is going to look like. Okay, and we know my x-intercepts. Okay. Next says we are increasing for temperatures less than 57, and we're decreasing for temperatures greater than about 57. So what is that? 57 is going to be what?
The maximum.
It's going to be part of it. What part of my graph is it, Janiyah? What is 57? Symmetry. Yes, it's going to be the middle. Okay? 57 is going to be my middle. So we're increasing until we reach that 57, and then we're decreasing again. So 57 degrees is about right here-ish. But again, I don't know how tall it is. I know this is going to cut it in half, but I'm still not sure where that highest point is going to be. Okay? So look what's next. Relative maximum. Where's the highest happiness reading going to be? What does it say specifically, though?
87. 89.
85. 85. So it tells me our relative maximum is so at about 57 degrees is when a person's happiness is scaled at about an 85. So now I can finally plot my maximum point, right? So about 85, I can put it right about here.
Wait. So like right before the 60?
What? That's the 57. That's the symmetry we got before, right? And then now I know that my vertex is at 57.85. So now I know the y value. I know how high I can go. I knew where it was on the x. Now it told me that 85 was how tall we can go. And now we can connect. Now we can make my parabola. Yep. So we're going to go up, reach our maximum point, and then we're going to come back down. Like that. Okay.
Oh, I see.
Does that make sense? Well, make sure you reach that maximum point. Okay. My end behavior, it does match. It says as temperature increases or decreases, a person's happiness decreases. So as x goes to the left or as x goes to the right, do we agree that both sides are going down?
That doesn't make any sense.
Does that make sense? Look, are both sides going down? Yes. So that our graph matches.
Yeah.
One more thing to match has symmetry. A person's happiness for temperature less than 57%, degrees, is the same as their happiness greater than 57 degrees. So we have that marked down correct as well. So we're using information now to help us create the graph. Right? So when do people have a happiness of like nada? Like they're not happy at all?
Whenever it's hot.
What shows when their happiness score is a 0? What two temperatures show a happy score of 0?
25 and 89.
There you go. 25 degrees and 89 degrees. Showing people are like have a score of 0, happy score, because that's really cold. And I guess people who aren't in Florida, 89 is really hot.
No, it's not.
For us, that's normal, right? And then so next question, when are people the most happy? At what temperature? When are people the most happy according to this graph? What's the temperature they are the most happy?
85. 27. 57.
Hey, y'all are guessing.
57.
We're looking at our maximum. There we go. The temperature is 57. 85 was their happy score or whatever you want to call it. Okay? But look, temperature is the X value. So they are the most happy at 57 degrees. Okay? I'm with you. I think that's too cold also. All right. Any questions for me so far?
Look at my desk. What is that?
Okay. All right. We have Mariana. She used key features to sketch the graph of x as a function of y. Examine the key features and graph to identify which key features she graphed correctly and incorrectly. Okay, so does she have the graph being positive between x is negative 3 and x equals 0? So let's start with that. Between x is negative 3. Can y'all see that? Let me change it to orange. There we go. X is negative 3. And in between those 2 points, are we going up? Are we above it?
No,
Yes, so we are above the x-axis. We're good. Okay? When x's are bigger than 2. So from 2, here's 2. Right? So when we're bigger than 2, does my graph continue to go up?
Yes.
Yes, so she did graph this correctly. That is good.
So wait, what is cut? Like a check mark?
Yeah, check mark. All right, did she graph negative for when x's are less than negative 3? So back to negative 3, less than means over here. Are we going down?
Yes.
Yes, so that's good. And then in between 0 and 2, are we going down in between 0 and 2? Yes, so she also graphed the negative piece correct as well.
The next one's incorrect though.
The next one's incorrect? Why do you say that?
Because in here it has a negative 2 and it doesn't have a negative 3.
Okay, let's look at it. Here we go. Increasing when x is less than negative 2 and between 1 and 3. Okay, so negative 2, I'm going to change my color so we can see better. So here's x is negative 2, right? So I would say less. So yeah, coming up to that point, we are increasing. So that part's fine. And then in between 1 and 3. So here we go. Here's 1 and here's 3. Are we increasing between 1 and 3?
Yeah. I'm wrong. No, we're not.
I'm saying yes, but why does my answer key say that it's wrong? Hold on, let's see.
Am I right?
I can look for you. No. I'm good with technology.
Less than negative 2, we are increasing. And between x is 1 and x is 3. Oh, you know what it is? Hey, stay with me. The problem is my graph does not stop at 3. Okay? The graph does not stop at 3. So technically she's incorrect. We should say just greater than 1. It should have said greater than 1. Because it's going to continue to increase as it keeps going. So that was the problem. Okay? Saying between 1 and 3 shows that it stops increasing at 3. And that's not happening. It's going to keep going.
So the next one's right.
Okay? Let's see.
No, it's wrong.
Let's see.
Because it's decreasing, not increasing.
All right, let's see. Decreasing when, let's see, in between negative 2 and 1. So here's negative 2. Here's where x is 1. All right, I agree that that's decreasing. Y'all, stop talking. I shouldn't hear my voice and someone else's at the same time. Okay. And then when x is greater than 3. So this is 3. Is it decreasing after that? No, we said it was increasing, right? It continues to increase. So this is also wrong. I'm going to put x's over here. I'm going to do x's. Wrong. She did not graph that correctly. All right, next little bit. The graph, so we're talking about intercepts. The graph intersects the x-axis at negative 3, 0, and 2. Do you agree with that?
Yes.
Yes. We actually already plotted those points, didn't we? Because we used it for the beginning. So yeah, that is correct. All right, do we have a relative minimum at about 1, negative 2?
Yes.
So remember, an x of 1 means I go right? I go right 1. And then negative 2 means we're going to go down. So over, down. Is that a relative minimum? Yes. Because it's the bottom of a dip. Okay?
The next one's a nose.
You think so?
I think so.
You know so.
I did not work.
Why is the next one a no?
We have a 4. We have a deal of 4.
All right, well, let's see. So this is a point, right? -2 and then +4. Stop talking, please. We're almost there. So we're going to go left. We're going to go left, and we're going to go up. So from here, left 2, 1, 2, and then up 1, 2, 3, 4. So that one's fine. Okay? But how about 3, 2? 1, 2, 3, up 2. Is that a part of a turn? No, it's not even on my graph.
That's how it was on too, man.
My next piece, we have in behavior. Okay? As x increases and decreases, the value of y decreases. So it's saying as my x's get bigger and as my x's get smaller, that both of my sides are going down. Is that happening on my graph?
No.
No, that is wrong. Good. The left side is going down, but the right side is going up, right? So that was the part that was wrong. As x increases, y actually also increases. So that part's wrong. We good? All right, one more little piece. We got this. All right, use the key features to identify which graph or graphs match these details, okay? So multiple choice, let's cross things out once they don't match what we have, okay? Positive for all values of x. Are there any graphs that show only positive y values? All values of x, excuse me. X's are only positive. Positive for all values of x. So this one's going to be out. Okay? Because it dips down under the x-axis. Okay? So that one's not going to be all positive. The other ones are all positive. They're all floating above the x-axis. Okay? So this one is not A. Okay? So A is out. All right. Increasing when x is bigger than 1. Remember, the arrow is pointing for you. So on the right side of 1, are we increasing? So here's 1. Are we increasing on this side? Yes. All right. Here's 1. Are we only increasing on this side? No. So not C. Here's x equals 1. Are we increasing on the right side?
No.
Yes.
Oh, shoot.
Yeah. So that one's fine. All right. Decreasing when x is less than 1. So on the left side, are we going down? Are we going down on this side?
No.
Yes. Are we going down on this side? Yes. Okay. So far they're both in. Relative minimum at 1, 4. So we already have my 1s, right? We already have those marked. 1, 2, 3, 4. That's a minimum, right? Over here, 1, 2, 3, 4. Okay, they both have the same minimums, so that's fine. In behavior, as x increases and decreases, okay, so it's saying on both sides, y is increasing. So are both sides going up?
Yes.
Yep, B is both going up, D is both going up. Okay. Symmetry. The right half is the mirror image to the left half, where x equals 1. I already drew that, didn't I?
Yeah.
Are they both symmetrical? So guess what? It's both of them. So B, there we go, B and D. All right. Good job. Beautiful. Sandpapers. Get them out. Now we can do our Chromebook stuff.